webinar, but I love open source. Why do I need SAS Viya? My name is Tiago de Souza. I am a digital marketing specialist here at SAS, and I will serve as your moderator for today's event. Now, I would like to take a moment to introduce our presenter, Marinela Profi, Global Product Marketing Manager of Data Science, ML Ops, and Open Source Integration here at SAS. Marinela is responsible for the integration of SAS Viya with open source technology and model ops practice. Previously, she worked as an analytic and AI consultant. She is a keynote speaker and presenter at different global conferences on data science topics, and she holds a master's in statistics and a Master of Business Administration degree. Now, before we get started, I wanted to let you know that we will share the slides after the webinar in the Ask the Expert community. There is a link to that in the resources widget, and it will be in our follow-up email after the webinar as well. With all of that out of the way, why don't we turn things over to our presenter so we can get started. Marinela, please take it away.
Thank you, Tiago. Thank you, everyone. Welcome to this session. Thank you for joining. It's a pleasure to be here today. So I am going to go ahead and share my screen. I've actually asked Wendy, my colleague, to help me today due to some technical difficulties. So thank you for your patience there. So we just a little bit of agenda, what we're going to see today. Tiago presented me. Thank you, Tiago. We're going to start a little bit about, seeing which are some of the challenges that our customers, organizations in general are facing when they're trying to implement and invest on AI analytics. We know that open source is a big choice, and we know that has a lot of potential, and our customers and organizations are adopting it more and more. So we're going to go ahead and understand a little bit about also the ecosystem of open source, that it's available and is being adopted. And then we're going to move forward in looking at how SAS integrates with open source. We have done huge investments in the past years to to extend our integration with the open source ecosystem and the value that we deliver through that integration. And last but not least, we're going to leave, of course, some time for Q&A and to interact a little bit on the contents. So if we move to the next slide, we always want to start the conversation sort of putting our customers at the center. If we go to the next slide, we can take a look at the challenges that organizations face when it comes to deploying AI in analytics. These challenges, so most of the time, appear in 4 different categories: data, technology, process, and people. Now, with respect to data, very quickly, a few words on each of this. Challenges include lack of governance, centralized provisioning, and centralized access to data. And that means a lot of silos and possible duplication. It also includes challenges in monitoring the quality of the input data that we are using to build our models, to make sure that we are using significant and unbiased data. With respect to technology, we use a variety of tools today, which makes it difficult to scale analytics. And we know how important that is, the ability to scale analytics, to control the versioning of the tools that we're using in all the languages that we're using. People problems can be significant as well. Skills and knowledge are very scattered throughout different teams in the organization, and there are still pretty high costs and time when it comes to recruiting data science and developer skills today. And finally, process. The silos we just talked about across data, technology, and people make it exponentially more difficult to have a unified and a consistent process for deploying models, monitoring them in production, and make sure that they are useful and valuable, not just in the short term, but most importantly, in the medium long term. And the lack of governance and documentation and interpretability makes it much harder to know what models are going and whether it's performing well. So organizations who are using purely open source we have experience in dealing at least with one of these challenges in their journey of adopting analytics. And more than likely, they're facing multiple of these challenges. And unless resolved, these challenges will begin to impact business outcomes in terms of increasing the cost of analytics and reducing the innovation. Now, analytic projects are getting steamed, and many organizations are interested in open source technologies. And before we move further, I just want to take a moment in the next slide to understand a little bit about the open source technology ecosystem and choices that are available and mostly utilized today. So this is a little bit of a simplified view, but it shows the most popular technologies and where they fit within different open source categories. So the first categories that I represented here today is languages. These languages usually include Python, R, Java, Lua, and many others languages. The second category is open source libraries. Each library includes different capabilities around the AI world, with different procedures that our programmers can use and personalize on the basis of the business case that they are looking to solve. There are hundreds of libraries out there, and all of them have various degrees of development efforts behind it. And then there are open source technologies that focus more on areas such as data, deployment, automation, monitoring, etc. Now, individually, these are all very powerful tools. And a typical example, based on my experience, has been, for example, the Hadoop ecosystem seems to be the to-go choice from the open source to collect and aggregate different data sources. Things like Hive and HBase fit the bill for accessing, mixing, matching multiple sources of data. For data preparation, like curation, exploration, feature engineering, Apache Spark can be really useful to slice and dice large data sets through Spark SQL, even leveraging, in-memory processing to speed up response times. Spark also gives you, natural language processing capabilities, feature extraction, such as the principal component analysis, just to mention some of those. And then we have, all the libraries, the massive variety of scikit-learn, R, SparkML, TensorFlow, Keras, PyTorch, and among others, which provide basically almost everything that myself and my data scientist fellows could ever dream of. And finally, tools like Docker, Plumber, ease the deployment of machine learning models in the form of web services, consumable through HTTP requests. And so my question will be, wait a second, if we move to the next slide, a question that we can answer, we can wonder could be, does that mean that we could build an enterprise-ready end-to-end AI system solely using open source stack? Well, this is actually a little bit more complicated than that. This can be a great for a proof of concept, but collectively, as you build an analytics solution with this ecosystem, we find out that there are some important questions that we have to consider in each of these categories. And so if we move to the next slide, what are these questions? Now, if we look at the different categories that we analyzed before, for open source languages, Python and R are very dominant, but different skills are needed depending on use of libraries and data sources. And because of open source languages are primarily coded, how do organizations democratize the use of AI beyond the programmers, such as how do they bring in domain experts and business analysts? Other important considerations is when it comes to libraries, how to improve the productivity of the data science team, how to ensure models are transparent and explainable that are created in these different technologies. Governance is such a key important topic, how to ensure governance across the entire ecosystem. And we know that deploying models has challenges. We're going to go in a little bit more deeper later on that. So what about model ops or ML ops? And finally, from a technology standpoint, questions such as how do we connect different technologies with different and new data sources? Which library has the level of security that is consistent with my policies if I am a bank or if I operate in a very highly regulated industry? What level of performance will I get from the final solution given the mix of the technology that I'm using? And finally, as I need to scale out this solution, where can I get help to build a robust solution? So these are all questions that remain open when we are adopting only open source. And I just want to say something, like, don't get me wrong. I'm not only a big fan, but also an avid user of open source myself. I am a Python programmer. That's how I started my career. And I do realize that there are so many fantastic tools, but at the same time, there are quite a few gaps when we consider to move to something that is sustainable in the long term, and we move from a researched AI, which is the one that we do in the academic reason or in the research field, to something that it's meant to support an enterprise and a business. Just a quick personal funny story. Last time I tried to install TensorFlow on my machine, it broke my Apache Spark configuration. And a few minutes later, when I thought I fixed Spark, I realized that TensorFlow was toast again. So long story short, it took me an entire afternoon to get these two beasts up and running. And imagine how many things could go wrong when so many other tools need to coexist within a data scientist working environment, like Jupyter, R, XGBoost, Hadoop, TensorFlow, and the list goes on and on. And consider that all these tools have new releases every other month, frequent versioning updates will be needed, and so on. So if we move to the next slide, considering these questions that remain unopened, where does SAS fit in? Well, this is an ideal problem for SAS to come in and solve. Across each of these areas of languages, libraries, and technologies, SAS works with open source and integrates with open source in each step of the machine learning and AI and analytics journey. What do I mean by machine learning and AI journey? So if we go to the next slide, we can see that the journey or the life cycle refers to, it's important that we consider this in its entirely, the analytics life cycle, which refers to that sort of, can we just go back 1 second to the previous slide, Wendy, please? Thanks. I just wanted to mention one thing that I think it's important here to say, that when we talk about journey and life cycle, we refer to that sort of end-to-end process at a high level, which starting from data allows to, get to a decision, which a decision is not just the output of the model, but also how do you use the output of that model? How do you integrate and embed that output into your business objectives, functions, and processes? And the reason why it is important that we consider the analytics life cycle in its entirely when we talk about investments in analytics is because if we want to create value from data, all the aspects of the analytics need to be connected, and the process needs to be highly operational and seamless. So it's not sufficient that we have the best data ops process or the best team that develops the most accurate models, because it's so much more than that. And so in the next slide, we will dig into each of these into more detail to really demonstrate how SAS works with open source. So let's start from the first, choice of language. SAS supports some of the most popular open source languages, such as Python and R. We understand, that there are different parts of your organization that will have different skills and different technologies of choice. For example, I'm a Python programmer, and if my organization has an AI underlying platform like SAS, It shouldn't make any difference for me. It should just be a plus, something that makes my daily job easier and makes me collaborate more easily and more efficiently with the rest of the personas in my organization. And some will use SAS, some will program in Python, some will program in R. And so what SAS does is really gives you the ability to develop models as well as build and analyze data using the language of your choice. You can use SAS, Python, R directly within SAS. So think of, Jupyter Notebook. SAS has, of course, its own notebook environment. You can write either SAS or Python language directly into SAS and run that native code directly into SAS. So the different personas can use the same interface and collaborate. Or you can use your Jupyter Notebook or your R Studio and using that language while still using SAS libraries that are available on GitHub, specifically designed for open source notebooks, while still leveraging SAS in the background as a running engine. You can run open source models within SAS with our coding. We will go a little bit deeper into that when we will talk about how to operationalize the models, how to implement model ops framework. You can call open source from within SAS using APIs. You can monitor both SAS and open source models together from a single repository. So no matter what the language is, you can make sure your models are working well as well. Moving to the next slide, the second element that we want to answer, the democratization of analytics. So we know that analytics is, most powerful when it is used by everyone in the organization to make better decisions. This means that data scientists working with business analysts, working with domain experts, this collaboration is important to get the most benefits. And this is why SAS includes both programming interface as well as point-and-click visual interfaces so that more personas can use analytics and you are able to truly democratize. So if you're a programmer who likes to use SAS or Python or R, then you can do so. If you're more comfortable using a visual interface for analytics, you can do that on SAS as well. In fact, some programmers, we see in some of our customers tell us that data transformations are done faster and more efficiently on the visual interface, which has also some other, features embedded like automated feature engineering and auto-tuning capabilities. So all the capabilities that we will show and we will talk about, it's just, remind that they are accessible from different interfaces. We support APIs to access all our capabilities from simple to use GUIs, RESTful API calls, command line interface as well. Packages and libraries that are posted on Git and SAS code. So, it's just a matter of choosing what's the approach that works better for you. Moving to the next element, to the third one, here we talked about the team productivity. So how we make sure that the team productivity keeps increasing over time. Data preparation and manual coding takes a tremendous amount of time and skilled resources. We know that that's one of the most painful steps in every AI projects. It takes around the 70%, if not even more, of an entire project. So ingesting the data, making sure that we're using the right format, the right data, quality data, and different sources available. And so this time is better spent innovating and putting in those insights into production. SAS automates many of these time-intensive tasks to improve productivity of the data science team. For the data scientists, that means that we can automate data preparation, machine learning through AutoML. We can use machine learning in the data preparation stage to ensure highest quality prior to the modeling stage. So all that unbiased problem that I was mentioning before, the observability issues related to data inputs that are not good quality. And so basically we spend so much time just building on something that it's not right to begin with. For the business analyst, SAS automates explainability. Every model, and I'm talking about SAS and open source models. When I talk about model, I always mean SAS and open source models. It can be Python models, R models, different Python libraries. Every model comes included with explainability in plain language. So organizations can understand the decisions made by these models. No black box. And finally, for the IT team, SAS automates monitoring and retraining of the models, both SAS and open source, to ensure that we make accurate predictions throughout the entire life cycle. And this improves highly the productivity of data science resources and expands AI capabilities to those with more widely available skill sets. Next slide. We talked about transparency in responsible AI. These are probably some of the most important part of analytics project, I would say, making sure that what we are putting out there, the way we're using AI in our data, it's responsible, it's ethical, and will stay like that in the long term, even if external conditions change or external regulations change. We know that when we talk about open source, different libraries have varying approaches to how they implement transparency. And from an industry basis as well, some industry standards frameworks, some libraries use industry standards frameworks such as LIME, ICE, PD, while for others, it is out of their scope. So it's important to ensure that the decisions our models are making are equitable and transparent so that we can explain these decisions easily. From a data standpoint, this means having the ability, considering bias, flagging PII, personal identifiable information, showing lineage of all operations performed on the data set. For analytics, this means explainability in simple language. So all can understand how and what the models are predicting. Again, it means lineage information is preserved to understand what changes were made to the models. From a deployment standpoint, this means that models compliance for the life cycle of the model. So we are making sure that it's ongoingly compliant with our business processes, and we're able to monitor that. And so SAS helps ensure transparency across each of these areas in a consistent manner. Next slide, please. Governance. As AI and machine learning become more widespread, organizations struggle to trust data, understand usage, ownership, and properties models, and foster ethical adoption of AI. SAS includes centralized management of all open source and SAS models, data lineage and templates, giving you full visibility and control over all your data and analytics activities. You can track all your projects from a single dashboard to understand model development in the different phases, ownership, versioning, what version of that library was used, who did that model, when was the last time that model was changed, what version of Python was used, does it need an update? Those are all learning that are embedded and are integrated with SAS. And finally, our analytics lifecycle includes testing models prior to deployment. Testing, it's a very critical step before we go in production. And making sure that that step is integrated into the platform, it makes a big difference in terms of having the different steps streamlined and connected together. So we do not have to separate that, and we do not lose track of the testing versus how things are going into production. If we go into the next slide, one important aspect of the governance that I want to focus for a second and spend a little bit more time is data governance. This is one of the most important aspects to me. We talk a lot about model ops, how the deployment is so important. But the data is really what makes the difference. Governing data assets and create a data pipeline for downstream use, whether it might be reporting or model building and deployment. With SAS, the user can inventory, search, discover, profile, interpret, and apply semantics as well to not just data, but also reports, analytics models, decisions, and other analytics assets. So information catalogs enable, data governance, capture robust sets of attributes for each asset, and enrich metadata to determine current and future state and use. If we go into the next slide, or personalizing analytics. Despite building highly accurate models, organizations are hitting roadblocks moving these models into production. In fact, a large majority of models are created, but researchers show that if we consider, for example, all the organizations that began an AI pilot in 2019, 72% of them have not been able to deploy even a single application in production. Models do not make it in production. If they do, they break because they fail to adapt to changes in the environment. You can only imagine how, these result in significant loss of money, investment, time across the organization. Teams engage in high degree of manual and one-off work. They do not have reusable or reproducible components, and their processes involve difficulties in hands-off between the data scientists and the IT, which are usually, from what we have seen, the two personas that have sometimes the most struggling in collaborating effectively. So organizations need an automated and streamlined process, and this process does not just help to successfully deploy machine learning in production, but it also helps manage the risk when organizations scale the number of applications to more use cases, and it helps also ensure that the applications are still in line with business goals. So this is why SAS includes Model Ops framework embedded as an integrated step of the platform. It gives you the ability to register the models for governance and versioning tracking in one single hub. And speaking of open source models, SAS models, text analytics models, models that are based on different types of data, structured and unstructured. Test the models with real-world data to confirm accuracy and deploy them into batch or real-time systems are needed. If we improve business outcomes. So if we go into the next slide, I have prepared a very short, video. So this is an overview of the SAS Model Ops environment. I have provided a couple of screenshots from it to make it easier for you and more personable and approachable of what I'm actually talking about. What it does, it basically provides an industry-leading framework for model ops, enabling collection, testing, deploying, monitoring, governance, and retraining of models, regardless of what language they're written. So SAS, Python, R, etc. You can see that in this environment, for example, I have more than 1,000 models that my organization is actually using now, and 77 of them are in production, which means that are published. That's the term that we use to refer to a model that it's in production. I can see what type of score code I'm using, and I can see where my models are running in one and central environment. The deployment environment, so where can I publish my model? Where can I deploy my models using SAS? Include different types of destinations. You can use SAS Viya in memory engine. You can use SAS, you can deploy the models in microanalytic service, Amazon Web Services, Azure AKS, Azure Machine Learning, private Docker containers in database, using Teradata and Hadoop, Azure Synapse and GitHub as well, if you're interested. And if you're interested in using RESTful API calls to score new data against your model, I'd recommend, for example, using our microanalytic service option, which is a threaded compute environment offering clustering for high availability to DS2 and Python programs for a sort of a compile once and execute many times usage pattern, and comes with the SAS platform integrated. Now, one important thing that I want to mention here is that no model recoding is needed. When you push your model from Python, from your Jupyter notebook, or from RStudio, or from wherever you have programmed that model, and you pushed it into SAS, recoding it increases the likelihood of failure. What SAS does, it maintains the models in the programming language they were written in by generating Python-based containers that run Python-based models, as well as R-based containers to run R-based models for use in private Docker, AWS, Azure Machine Learning, and Azure AKS, and et cetera, et cetera. It's also true, though, that many of our customers want to execute batch scoring for their Python-based and R-based models. And they use our SAS Viya memory engine or score individual records via RESTful API calls with the real-time scoring engine. With the latest stable release, now you know that SAS Viya, now we have moved into a continuous integration, continuous delivery, monthly releases. With our latest stable release, you can now publish models using a lightweight compliant Docker container for executing. It provides a modern, bulletproof, reliable, and non-proprietary system for transferring and executing runtime code. This will greatly simplify efforts to move code from your development system to your production system using immutable containers. So what it means is that you can simply register then your containerized model to your favorite cloud, GCP, AWS, you name it, or Docker location. Or you can even create an app or use RESTful APIs to score new data against your published models, leveraging the SAS container runtime. If we move to the next point, data access. Now, as we know, new data sources are becoming available every day. It is possible to connect to these open technologies. However, you have to use the right libraries and tools in order to make the connection, if we think that from an open source standpoint. And this can be a very time-consuming effort. SAS comes with out-of-the-box access to almost every known data source, from different types of databases to distributed file system, local files on laptops, desktops, and even for data mainframes. There is no need to find libraries that have the right security protocols or governance features in place. SAS simply has that included. And, just an example, latest releases include extended support for Databricks, Spark, and in database scoring for Synapse on Spark as well. The next one, in the next slide, we talked about performance, how it is a very important consideration for analytic solutions. As the application scales out, it will perform as fast as the slowest bottleneck in the integrated solution. And this is where SAS really shines. It can scale to match the size of problems of every size using capabilities such as the MPP, massively parallel processing technology within SAS, which can string together hundreds of processors working collectively on a problem, or in database processing, so that data is never moved away from the source, saving time and effort. Multi-threaded processing that makes maximum use of processing power up to 100 times faster than single-threaded operations. And finally, in-memory processing, which keeps the most used data in memory versus lower storage to improve overall application performance. And these are among other architectural capabilities that SAS uses to ensure higher performance analytics for your organization. Moving to the next slide, last but not least, once you have decided on an analytic solution, building it yourself with different technologies can be a long and complex task. And this is where SAS consulting and managed application services can help deliver a finished solution for the people who know SAS best. So consulting services include developing your analytic strategy, modernizing your environment, advancing industry expertise, minimizing your investment in analytics. SaaS managed application services, on the other hand, can help you design your solution, host the solution with a single SLA across the entire hardware, software, and application stack, or incorporate cloud services seamlessly, such as security, authentication, database service. And finally, as you consider expanding and furthering your skills, SaaS support and education can help with, resources, including many at no cost to keep skills current, class support and documentation to provide help when you need it, and a rich community of SaaS and open source users to take pride in collaborating with you. Now, before we wrap up, I just want to take 2 minutes to show you in the next slide, some action behind what we just talked about. By just showing you, if we go ahead and play this short demo that I recorded with you, the model ops environment that I mentioned before, that it's integrated within SaaS platform, the model ops framework. So this is a model ops environment, which we refer to internally as model manager. The interface is pretty much divided into several, tabs. And the one that you're looking now is the homepage, where you and your team can have access to all the models and all the projects you're working on. On the right side is all about collaboration. You can see all the what's new, how-to videos, and all the new releases that we post. If we go ahead and open a model, this ONNX model, when SAS ingested that ONNX file, just to give you an understanding of what happens behind the scenes, all the supporting assets, it automatically created SAS core code, so it can be operationalized. You can also track the variables of the models and have access to the properties of the models, like, as I mentioned before, which version of Python was used. As well as the version of these models, we are currently using a second version of the models, which was deployed by this user. This is the homepage that I said before, that I briefly mentioned. You can see here that we have more than 1,000 models, 77 of which are deployed. We can see where these models are deployed by different score code type. We have some Python, some R, some Java, PMML format, SAS format in DS2. We can filter to see, for example, that we have only the Python models here, which version we're using, what type of model it is, if it's an image classification, a computer vision, who was created by, when was it last time modified, and also, where is it deployed? To make it, the publishing status as well, and to make it easier to sort of look at the different repositories and think of a project here. You can also see the different types of projects. Think of a project as a collection, as a business problem. In the same project, you will have multiple models that different people have worked on and have pushed into their project. So to make it easier to look at different repositories, I can go ahead and look at the operational status of my models. So filter by am I prototyping? Am I looking for something that it's in deployment? What type of model function? It's a segmentation, it's a computer vision, and whether or not has been deployed. And so where? Having access to all my different environment that I have configured. And so these are, among other things that I can do in my models, the model ops framework. Moving to the next slide, before we open for questions, I just want to conclude with a success use case. We worked with one of the biggest US leaders in the manufacturing industry, which, for privacy reasons, I'm not going to mention today. However, this is a public story available. This was developed last year during the pandemic, where we know that the manufacturing industry, and it's still a problem, I mean, we're still facing some of those problems, had peaks and unpredictable demand issues. The organization really wanted to integrate more data and analytics into their everyday decisions. they were using Python and R for analytics as well as SAS. There were SAS customers as well, having a different type of base, but they were looking to they were using Python and R, and they were like, how can we leverage SAS to make sure that our open source are successful as well? Because we're having some problems. And when the problems, if you move forward in the slide, Wendy, please, and click for me, some of these problems, have when they try to integrate the solutions into their day-to-day process and systems, they had difficulty in accessing petabytes of data in real time. It took more than 3 months to bring a model from the lab to the production. And this was compounded by high turnover in their technical workforce, which, it was a big problem last year, and it still is, if we want to see it. So what happens after they implementing SAS, and we started working with them in integrating the capability that SAS has to work with open source? If we move to the next slide, here are a few quotes from the customer itself. They have today more than 1,900 models that are running multiple times a second. Each one of them is developed in a language of choice. We can be SAS, Python, and R, because they have different programmers with different skills, and then is deployed in SAS. It used to take them 12 weeks to deploy a model. Now they have seen huge increases, performances, and times reduced between 3 to 6 weeks, and sometimes even shorter than that. They have been able to include more personas in the model building phase within minutes and not hours. And finally, they're able to improve productivity of the data scientist team by automating mundane tasks and get the team focused on more value-added and complex problems. And so in the next slide, in summary, just to leave you with some reminders from this session, what we saw today is that SAS integrates with open source in every step of the analytics journey. We help teams use the language of choice, code in the interface of choice, deploy models in every destination while ensuring model ops framework, governance, monitoring, versioning, retraining, and integration of the different components. As part of our continuous integration and continuous delivery with monthly releases, we are looking to expand the list of model types and languages supported. We're continuously developing out new out-of-the-box performance monitoring support for a broader list of model function. We're looking to expand the list of models, publishing, and deploying destination. And we plan on really pushing and promoting SAS container runtime for use in all clouds. Essentially, we are working on creating a system that allows you to always know where your models are and what they're doing. And with that, that's all I had for today. I'm going to hand it over and open for some questions and hand it over to Thiago to wrapping up. Thank you so much. Yes, here are my contacts. Just one last thing, Thiago. Sorry. Here are my contacts in case you want to, reach out for any question. You can do it in my email or my LinkedIn.
Perfect. Yes, like she said, we will be moving into the Q&A segment of the webinar, but first, let me tell you about an upcoming SAS Learning Conference, The Power of Connectivity. It is a one-day live virtual event on November 18th. There's going to be multiple bite-sized sessions on hot topics and opportunities to network as well. So be sure to sign up for that through our resources widget. Now on to the Q&A. A quick reminder here on how it works. If you would like to ask a question, simply type it into the yellow Q&A widget located at the bottom of your screen. While we queue up your questions, we would love your feedback on our webinar today as well. So please take a moment to fill out a quick survey by clicking on the purple survey widget that's also at the bottom of your screen. It is only 4 quick questions and will only take a minute to complete. Your feedback is super invaluable to us, and we will use it to shape future webinars. Now, let's see. First question for you here. How does SAS integrate with Tableau?
Yes, thank you. So Tableau supports SAS data sets as a data source directly the last time I looked. Now, SAS is also true that we have our own it comes with its own Tableau sort of. We have the visual analytics that comes with SAS. And Tableau supports SAS data sets. So that's how it's connected. And there is an ODBC connection that it comes with it. So I can send you more information on that because there is a whole documentation. It's a question that it's really hard to just explain by voice, but I'm happy to share with this person the documentation behind it, which shows the step-by-step process.
Perfect. Thank you. Another question here for you. It's kind of a three-parter. When connecting to CAS with SWOT in Jupyter Notebook, does this enable them to utilize the computing power of Viya when running their Python code? They say, if so, what runs locally and what runs on the server? And then how do they specify what they want to run locally and what they want to run on Viya?
Yeah, that's a really good question. And it will probably, I can talk a little bit about that, but I'm sure that, someone from R&D can as well expand in terms of running computation, so what runs on the server and what runs locally, because that depends on a lot of other elements as well of what you're trying to run. So we have different libraries. We have a proc Python, and we have different libraries like the SWOT that we have specifically built for use in the Jupyter Notebook. That includes a lot of SAS actions that they can run in the Jupyter Notebook, leveraging the SAS engine on the background. And so that is how it works. By leveraging the SAS libraries on the interface, you can leverage the SAS engine on the background. On the other hand, you can use SAS interface, SAS Notebook, and you can simply run and write in Python if you have no knowledge of SAS programming language. You can use SAS Notebook to run the Python code and leverage completely just the SAS engine, whatever engine you're using and whatever you have installed.
Gotcha. Makes sense. Thank you for that answer. We have another question here for you. Is the integrated model ops framework a standard part of SAS Viya? Yes.
It comes with the SAS Viya, so it's a module. So the platform is made of different modules, which of course it depends on. It's personalized on the basis of the customer needs. So if the customer needs a model ops framework, it is integrated in the platform, and it's pretty much what I showed before in the video. So yes, it comes integrated with the SAS Viya platform as a module that customers can integrate.
Perfect. We have another question here. Is there a visual demo that you know of or a use case on the SAS website that shows how Python is integrated with SAS code? And then does SAS internally convert Python code to SAS code when dealing with SAS data sets?
There is a visual demo, and there are actually several. I have some that I can share, but also on our SAS YouTube channel, we just posted videos around this. We can definitely share with the audience. Maybe Wendy or you, Thiago, can help me with sharing that. I forgot the other part of the question. Sorry, I thought that I remember there were two parts of that question.
Yeah, the second part was, does SAS internally convert Python code to SAS code when you're dealing with SAS data sets?
So what SAS does, basically, as I showed before in the demo, when you push your model, it automatically creates SAS core code for that model. So there is no need for the user to recode that. It's also true that the model, you can automatically create some Python-based containers or R-based containers and deploy the model in the native language without having to recode it. So it depends on where you are trying to deploy it. There is a lot of flexibility on how the model is handled, but the interesting and the beauty of it is that SAS does it automatically. So it creates a scorecard for you. So if you want to deploy it into SAS engine or into the SAS microanalytics real-time engine, you can use the SAS code, or if you want to use that in a container, it creates automatically the Python-based containers to deploy that into different environments.
Gotcha. Thank you for that answer. Another question for you. How does SAS support open source in the model deployment and management phase?
Yeah, so we saw this as well before. In the model deployment and management phase, the support of SAS, there is really no difference on how SAS treats open source and SAS models. And I think that's what is really the power of it, because you can collect, monitor, and govern and deploy in the same repository from the same interface, which is the one that we saw before. Models are written in different languages. So we have libraries and connectors that from Jupyter Notebook push the models into SAS, wrap it up, and push it into the environment to then deploy it. Same thing for RStudio. And there are demos out there that show this. I have demos on how to do this as well to share. But there is really no difference on how we treat SAS and open source models for deployment and monitoring.
Gotcha. Thank you, Marinella. I'm afraid that's all the questions we have today. Thank you again for chatting with us, and thanks to all of you for joining us. We have some helpful user resources and links here on our last slide. If you would like to view this webinar later, you can access the on-demand version via the same webcast link in your confirmation email and calendar invite. We will also be sending out the link to the on-demand version by email shortly. We will post the Q&A and slides in the Ask the Expert community. You will find a link to that in our follow-up email as well. On behalf of myself, Marinella, and all of SAS, we really hope that you enjoyed today's webinar. Thank you all, and have a great rest of your day.
Thank you.